All right, we're live and we can start. So welcome to this webinar. We're going to do kind of a joint hands-on lab today. And the idea is to show you how easy it is to get a grab of a full setup environment of a lot of JFrog products working together and get some, live experience with it. So this is me. My name is Baruch Sadogursky. I'm head of developer relations with JFrog. And you can follow me on Twitter at jbaruch if you have any questions regarding this webinar or everything related to JFrog, managing of binary files, CI/CD. I'm also CNCF ambassador, so any questions about Cloud Native Foundation, and especially Kubernetes and Helm, I will be more than happy to help in every way I can. So our plans for today. We're going to speak a little bit about what JFrog Artifactory is and what JFrog X-Ray is, what's their place in kind of an ecosystem and your development lifecycle. And then we're going to talk about the real live implications of working with those tools. So we'll see how we create an application WAR file, create a Docker-based image, create a product Docker image, tie everything together, and actually work with all those components. So what I would ask you to do now is to go to try.jfrog.com and spin up your file. It will probably take around 4 minutes to get set up and running, and we're going to talk about some basics while it actually starts. I would, while you're doing it and logging in and everything, I would like you to tell me how familiar we are with JFrog products. That will help me to gauge the level of my presentation to you. So I'm going to start the right poll here, and here we go. Please vote. I will give it around a minute, and then I will know what do you expect from me, basically. Okay, good stuff. So the majority of you are pretty advanced with Artifactory, and the majority of you are actually Artifactory admins and a lot of advanced people here that are less familiar with X-Ray. I see that here some people know about it. Most of the people know about it, but never used it. I guess this is kind of where we're going to do. We're going to do the Artifactory part a little bit quicker, leaving more time for X-Ray. I hear you. All right, okay. So I hope by now you have your environment spinning and getting started, and that will be a good time to speak about JFrog products in the life cycle of a developer in your organization or a software engineer in your organization. So everything starts with software engineers writing code. And the title here is a dev team. I think that's correct for the majority of the cases when actually developers write code using dependency on package managers, stuff like Maven for Java, or Gradle for Java, and NPM for JavaScript, PyPy for Python, Ruby Gems for Ruby, NuGet for .NET, obviously, etc., etc. But not only. Today, with our DevOps culture, every software engineer writes code, and we have a set of package managers which are kind of more about the ops part of the house. It will be using deb and rpm and using docker, obviously using helm for kubernetes, etc., etc. So software engineers write code, and when they write code, they use dependency managers, all dependency managers that you see. And when they add new dependencies to those dependency managers will go to repositories or registries to find their dependencies. And that's the first step when Artifactory comes into play. It will serve as the source for the dependencies that software engineers define. And you can see here on the graph, it's kind of on a border between a cloud and not being on a cloud. And that's exactly true, because you can set up, if you want Artifactory, on cloud or on-prem. And if you want the cloud, then you have all the major players covered. You can have the files will be retrieved and returned to the developer unless they are not found. If those dependencies are new, then Artifactory will fetch two remote repositories to fetch the artifacts from there. And it will be stuff like JCenter or Maven Central or NPM Registry or NuGet Gallery or any other remote repository. Once we bring new artifacts to our Artifactory, that will be a good time to scan those artifacts with X-Ray. And that's exactly where X-Ray first come to play. It will scan and analyze the new new artifacts, the new dependencies for security vulnerabilities, for license issues, and for other custom topics that you might care about. X-Ray, as you can see, as Artifactory can be installed on-prem or on the cloud, and it's actually important to collocate them together. So if you have Artifactory in the cloud, you will prefer X-Ray on the same cloud as well. And the sources of information for X-Ray to decide whether there are any security or license vulnerabilities are external data sources, both kind of mixed or private and public. You can see here a sub-list of that. Repositories of vulnerabilities such as National Vulnerability Database, and repositories of dependencies with their metadata, such as the ones that Ubuntu, Red Hat, and Debian maintain, and also others. So once the artifacts have been scanned, then now they can be returned to our developers back, and the developers can finish their tasks. And once the code is written, this code is obviously committed to version control, being your Git, Mercurial, Subversion, whatever you are using, the code is committed there. Next step, after the code is committed, your CI servers kick in. The CI servers actually perform exact same build as our software engineers perform in step one. So they will use the exactly same tools, and those tools will try to do exactly the same build, and they will obviously need the same dependencies. And those dependencies will again be fetched from Artifactory. And this time the dependencies will for sure be resolved successfully, because they are already in Artifactory. You pre-cache them in previous steps. So, so they will be resolved and the build will be successful. But after the build, now the artifacts that we produced, actually we want to preserve, because they are the product that we built. So now we have a new step, which is deploy the modules that we build, the artifacts that we build into Artifactory. So the deployment is not an interesting or unusual task by itself. Every package manager have their own upload, deploy command or publish command, and those that don't have it just usually kind of instruct to use a curl to upload files or any HTTP put. But there is something very important going on in the CI servers, and that's the creation of your product. This is what the CI server does. And being so important, it's important to gather metadata about creations of your artifacts. And this is where, again, JFrog comes into play. So depending on the CI server you use, you can use one of the tools provided by JFrog to collect this metadata. For Jenkins, you will have the Jenkins Artifactory plugin, same for Bamboo, same for TeamCity. For other tools, you can use the JFrog CLI, which is a command-line client for gather the information about the build. So you will run JFrog CLI commands into your CI servers and collect the metadata about your artifacts. This metadata, together with the artifacts, will be then deployed to Artifactory in number 8 of our diagram. Once this is done, and once we converted our sources into binaries, we start a CI pipeline. And CI pipeline is about ensuring the quality of the artifacts that you have. So we're going to speak in a second. We are taking our artifacts through a maturity pipeline from dev through QA, staging, production, all the environments that you have in your pipeline. And each and every step in this pipeline actually contributes more and more metadata. You have tests that pass, you want to record this. You have a penetration test passed, you want to record this. You have stress test passed, you want to record this. So all of them contribute more and more metadata. And one of the contributors of metadata is, of course, X-Ray, that again checks the artifacts for the security vulnerabilities and licenses in the dependencies, and also contribute metadata about those artifacts. This Docker image doesn't contain any Java security vulnerabilities in any levels. We're going to see how to do that. While our artifacts are passing those different steps, we want to deploy them into different environments or eventually deploy them to production. And deployment to production, if we are talking about servers that we control, either it's our servers in our data centers, or those are resources in the cloud, virtual machines, or serverless setups like Kubernetes, we are going to use different tools for doing that. And the provisioning tools are obviously, depending on what you have, it will be Docker, it will be Kubernetes, it will be Chef. And all those tools can use the metadata that would contributed earlier to ask questions like, which artifacts are ready to go to production? Which artifacts are mature enough to go to production? Now, if your artifacts are distributable instead of deployable, and you need to give them to your customers in a downloadable manner, there is a difference whether we're talking about external distribution or internal distribution. For external distribution, you can use distribution hubs such as JFrog Bittray to roll out your artifacts to distribution and then allow customers, whether they're people or machines or IoT devices, to download your artifacts through CDN in control and managed manner with entitlements, with EULA, with permissions, etc., etc. If we are talking about internal distribution, we have tools like JFrog distribution that will control the distribution and make it efficient and atomic and proven to Artifactory edge nodes, which are installed throughout your organization, and will receive those distribution packages and do with them whatever they need to be done with them. So this is kind of a big picture. And just to take a look at the same promotion pipeline now from a different aspect, you can see what we spoke about. That very quickly in our timeline, the source files are converted to artifacts through compilation or mere archiving of the source files together. And then those binary artifacts go through quality gates, which are small locks here in our diagrams. And those quality gates are actually the tests that we perform. And once the artifacts are allowed to go through the quality gate, they will be promoted to another repository in our artifact repository manager and installed to the right environment for testing, etc., etc. Those quality gates ensure the quality, ensure the visibility of the environment. For example, if the quality gates are repository boundaries, we can be 100% sure that only the right artifacts will get to the system setting environment. System setting environment won't be able to access stuff like stuff like production artifacts, and won't be able to see stuff like dev artifacts. They will only see the artifacts which should be in the right environment. So talking about X-ray, and as I mentioned, it looks like that's the majority of your interest in this group. This is more or less how X-ray looks like. So what we have here is a tool that realizes the component tree we have in Artifactory. You can see here that it takes artifacts to analyze from Artifactory and then parses the tree of the components within artifacts, going recursively to the smaller pieces. And you can see here a list of artifacts of artifact types that X-ray supports. And then once we have this tree, we can start and ask questions about it. So for example, do any of my artifacts in my entire component tree have security, certain security vulnerability, or does it have compatible license? Or maybe I want to find all the artifacts which are older than a certain age and see if they need to be modernized and refactored to newer ones. You can also plug in external metadata sources, and you can think about APM tool that reports about components being not performant enough. And then once you have them on a tree, and once you kind of realized which artifact you want to ask about, you can do impact analysis and ask where in my entire organization this artifact is used in any level, because I heard from my APM that it's not performant enough, and we need to replace it. And then of course notifications and everything else. So that's kind of X-ray in a glance, and I hope this is useful as well. So let's take a look of what the setup of try.jfrog.com gives you. This is what you get when you instantiate all the machines on try.jfrog.com. You have two Artifactory instances running on port 881 and 882, and they are an active HA cluster. They have a shared MySQL database. They have a shared Nginx that shares them on port 80 and 443 for HTTPS. And this Nginx also share ports 5000 to 5010 for different Docker registries. And since the majority of you are experienced with Artifactory, you probably know that Artifactory enables you to expose multiple Docker registries inside one Artifactory instance, and those Docker registries are actually filtered by port numbers or by virtual hosts. Here we use port numbers 5000 to 5010. This Artifactory instance is watched by JFrog X-ray on port 8000, and it watches this Artifactory to realize the artifacts into it. All the jobs that we are going to see are built in Jenkins on port 8080, and those jobs, the artifacts of the jobs being deployed to this Artifactory, and the dependencies being downloaded from this Artifactory instance. And for the jobs that X-ray that the Jenkins actually has, we have 5 example jobs pre-configured for you. Today we're going to talk about 3 of them, and that's an entire pipeline of building a Dockerized Java application. It all starts with a pure or a basic Java application that actually builds a WAR file. So we have a Gradle build that compiles and then run unit tests, and then Jenkins deploy those artifacts to Artifactory. Once those artifacts are deployed, JFrog X-ray kicks in, checks this WAR file, decomposes it to all the dependencies which are inside, and those dependencies are checked as well. Docker base image is the base image that we are going to do for our production. And what we're going to do is taking a base image of Ubuntu Trusty and then add our system dependencies from Artifactory. And our system dependencies are JDK8 and Tomcat. We're going to put it in on our Docker base image. And then we have it, again, we deploy to Artifactory, scan by JFrog X-ray. And here, the scan will do a Docker image scan and will find any problems inside our operating system levels, like, for example, vulnerable OpenSSH library or anything like that, but also Java scan, because inside Tomcat, there are jar files and war files that the Java capabilities can scan them and see what's going on. Also with JDK, there are jar files that can be scanned as well. And then we have our third pipeline, which kind of merges the previous two ones. It will take the Docker framework, and then it will add the war file into it. And then now we can test it with one of the pre-existing Gradle artifacts to see that it's okay. And once it is okay, we're going to deploy to JFrog Artifactory again, scan with X-ray, and now everything is scanned. Docker image is scanned for system vulnerabilities. All the system dependencies are scanned. Our war file is scanned. All the dependencies in our war file is scanned. Everything is scanned. And once this scan is successful, we can run a test on this new container and then promote it to be released. And this is how Docker actually works with all that. So first, we run a build. And once we run a build, we upload the build of Artifactory. Now, next, Jenkins instructs Artifactory or Artifactory plugin to run an X-ray scan. And what's going to do is this command will be passed on to X-ray, asking for an X-ray scan. X-ray scan will be performed, and then depending on the results, and of course we will see the results when we have something to talk about. So it will generate a violation, and then we will ask Jenkins to fail the job. And the JFrog Artifactory plugin will pass this request to Jenkins, and Jenkins will fail the job for us. So this is how the scan application in Docker application works. So now let's do it. Let me show you all this in our test environment in test.jfrog.com, try.jfrog.com. So let me just show you how it works. So this is try.jfrog.com. And if I sign here real quick here. Here we go. So that's my test. It's already running. I started it around 2 hours ago when I was preparing for this webinar. You can see the environment log, and here are the interesting parts of it. So you can have the username, it's always admin. You can have the password here and the URLs. Now, what you need to remember is that this IP changes for every different test. And if we want to build pipelines that you can use out of the box, we cannot rely on those IPs. So we're going to rely on host instead. And the host that everything is configured with is JFrog local. So in order for your demo to work, you need to change your hosts file to map the IP that you got on test drives with the JFrog local, and I'm going to show you how to do it in the next slide. So now we have JFrog local on port 80, and that's our Artifactory. I have JFrog local on port 8000, that's my X-ray, and I have JFrog local on 8080, that's my Jenkins. And this is where I'm going to start. And what I want to do with you is go through the pipeline that we spoke about. So let's start with the war file. The war file here, I need to log in again. I think I can do that. Here, my JFrog local admin. And let's see the configuration of this build. What I have here is a bunch of parameters that I'm using in my configuration script. And the interesting part, obviously, is the pipeline. So I'm going to copy it and paste it into something more suitable for showing code. That's the etc hosts. But what I need is a new file. I have a new file here. Didn't copy. Oh, what's going on? This is weird. My clipboard doesn't work. That didn't happen to me yet. Copy. This is so weird. Okay, I know where to find it. Instead, we're going to go to github.com JFrog training, and we will see the code right there. It's a very weird thing that happened. No. Should be Orbitera something. Okay. I think that's the one. Let's see. Yes, step 1 application. Yes. Okay. So that's exactly the same script that you see in Jenkins, just in more readable format. So what you can see here is that we are using JFrog Artifactory plugin. So we're going to use our DSL extensions to the JFrog Artifactory plugin, to the Groovy DSL to work, to configure the deployment to Artifactory and work with it. So I have a server URL here, and you can see here that the domain in JFrog local. This is why it's important for you to change to the right domain. And the URL is Artifactory, and then I create a new Gradle build, and that's the software that I'm going to use to build my Java build. And then I configure Artifactory and say, okay, that's my, I want to deploy artifacts to my deploy repository in my Artifactory server, and I want to resolve from a libs release in my Artifactory server. And then I want to capture the build information using the Jenkins plugin. Next, I run my Gradle. I say Gradle run, and then I provide the directory where the sources are, and we'll run build.gradle, and we'll run Artifactory publish, and that's a task that will publish artifacts to Artifactory, and this is the build info that we need to record all the information to. And once this is done, if this build is configured to run X-ray scan, we are going to configure the scanning to scan the job name that we just deployed and the build number that we just deployed. And we don't want to fail the build, or we do want to fail the build, up to us. And then we want to print the scan result. We want to print it in the logs of Jenkins, so we will be able to see it. So that's the pipeline. Let's see how it actually looks in the results, what actually happens when we run it. So let's take this one. It was a successful build, so we can take a look at the console. Okay, so here we go. Git checkout and everything works, and then here we go. We run a Gradle build, and that's our Gradle build. You see, that's the executable Gradle. We provide an init script, and that's what our plugin does. And we need this init script to set the resolution repositories and the deployment repositories for Gradle according to the script that we previously saw. And that's our auto-generated init script. And then it runs the command that we asked, which is clean Artifactory publish. And that's the build Gradle file. The build runs. As you see, it downloads the artifacts from Liz release as we asked, and then downloads all the dependencies, and eventually it deploys the artifacts to Gradle release, and that's the repository which was the release, the deploy repo that we configured. Once this is done, we gather and deploy the build info, and that's the information about the artifacts that we spoke about, and X-ray build triggered. So this is how it runs, and you can see the results on X-ray UI, but they are also shown here. And you can see here that it's actually one big JSON file that actually generated one alert. And you can see here the information about the alert. And again, you can go to X-ray and see it there. We're going to do it in a minute with all the vulnerabilities that were, and license violations and whatever, that were gathered during this scan. So we see here that we have a whole mess of vulnerabilities in our dependencies, but that's fine. We configured it to pass because we want to show you how X-ray works, but we don't want to fail our pipeline too early. So the next job will be building a Docker base image. So that's our Docker image template. That's our base image. And again, let's see how it is configured. Since I don't trust my clipboard anymore, let's see if I can see it here. So that's the Jenkins file. And again, what we are doing here is very similar, but now with Docker. So we say configure Artifactory server, and now we want to download the dependencies that we will need for our Docker base image, and that will be our JDK and Tomcat. So you can see here we use something that is called file spec, and that's a concept of a JFrog's plugin and JFrog CLI, and we say we want to download files that matching this pattern. We download it from Tomcat local into a JDK directory, and that will be our JDK and our Tomcat to Tomcat directory. And once we configured this pattern, we actually instruct our plugin to download those files. We obviously could use just wget or curl to download the files, but the difference is that when we do it using our server will record, our plugin will record those files as being dependencies for this Docker image, and we're going to see it in a minute in Artifactory. So once the files are downloaded, we can actually start the build. So that's our next step. And in this, we are going to just run Docker and then push the artifacts. And you can see here that it's very easy to configure Docker to work with Artifactory as registry if you use a Docker concept of our plugin. So instead of using like a Docker that Jenkins will give you, instead we create another Docker executable from our plugin, and it has a closure with registry that we can say, okay, I want to use Artifactory as a registry, and then do Docker login and Docker build, and it will automatically work with Artifactory as registry. Once we do that, we can do Docker push, and then we publish build info. Again, we have some tests, and then we have X-ray scan. So before we go into the step 3, let's review what happened in Artifactory during our first 2 steps. So you can see here that we have builds, and those builds are the build info that was deployed. And we started with the war file, that's the first one. And you can see here that all the Gradle modules were registered, and we can go to each and every one of them and see what's going on. So those are the files that we uploaded. Those are the dependencies that were used. All of them are in Artifactory, and all of them actually knew that they were part of the build. So I'm looking here at the jar file, and I can take a look here and say, okay, I want to see how this jar file was used. And you can see here, boom, it was used by 24 builds. And that's obviously all the builds that we have in our build browser. From here, I can go to any build that I like, see all the modules, go directly back to Jenkins from here. So you can see here, I can land on the builds results right over here and actually see all the details. I can compare between builds. I can say, I want to understand how this build differs from a previous build, from, let's say, build number 27, why it doesn't work, or 29, how it differs. What's going on? Oh, I guess I logged out. Yes, let me log in again. Okay, war file number 29. I want to understand how this build differs from build number 28. And it will show me the exact differences in artifacts, in dependencies, and environment variables, all that. So let's take a look at the Docker base image, because it actually has dependencies for Tomcat and Java that are completely like separate files that come from generic repositories. So it's kind of interesting to see how they are recorded as dependencies for our build. So this is the build image template. And you can see here that we have like a normal Docker build. It produced a bunch of layers. This is great. It also consumed a bunch of layers from the base image, which is wonderful. And you can see here they come from Ubuntu and stuff. This is like all amazing, but it's not really useful. But since we used, if you remember, JFrog plugin to download files from Artifactory, they were recorded as dependencies as well. And you can see him right there. Apache Tomcat and JDK Linux are actually registered as dependencies for this Docker image, and this is very cool. So now we have our war file, we have our Docker image, and now to the interesting of all of them, which is our third step. Creating Docker image product. And what we are doing here in our third step is putting to use the results of 2 previous builds. So getting back here to my step number 3, I'm in the right place. here, Docker product, I can look again at my Jenkins file and see what's going on. So what's going on here is very similar to what you saw previously, but now we are going to download as a dependency, as a file spec, the latest released Java war file. I downloaded it, I called it service.war, and now when I build my Docker build here, I can actually use it as a local file that I copy. And let me just show you here a Docker file real quick. You can see here that I take the file that I downloaded from Artifactory as a dependency using my Jenkins plugin. So I recorded it as a dependency. Now I add it as a WAR file to my Docker image, and now I can run it with Tomcat. And the rest of the pipeline is again pretty much the same, but here we have another step, which is the promotion. So after I have built, I deployed it to Artifactory. Now I have some tests that I run and scan it with X-ray. And if they are successful, both the test and the scan, I have another stage with each promote, and the promote have two different substeps. The first is promoting the build from source repo to remote set repo, and then I retag latest, and that's very important when working with Docker. So now I have two tags on this latest artifact. It both has a build number as for repeatable builds, and it also tagged with latest for the convenience of use. So the build promotion looks very simple. I just create a JSON promotion command that have this information of what I want to promote where, and then I actually execute this command on Artifactory server. And the retag latest is also a REST API that I execute on Artifactory server when I actually ask for retagging the build number with latest or the other way around. So looking again in Artifactory for the results of step number 3, you can see here that we have two different kind of dependencies types. The first will be a Docker build, and you can see here it has all the layers and the manifest. And the second module contains our WAR file that we produced, this one. If you remember, we downloaded it from Artifactory using Artifactory plugin. This is why it is recorded here. And since it is a file that we built in our step number 1, I can actually see how it was built, and going back to the build step number 1 right here from the file itself. And you can see here that I am in step number 1. So we created a metadata, bidirectional metadata between the Docker image and the jar file using the universal nature of Artifactory and using the metadata that we generated in Jenkins when we produced this file. And now to X-ray. Let's see what happened there. So this is X-ray for whoever never saw it. You can see here that we have a stream of recent vulnerabilities that we got from the databases that we work here. And you can see here that we have a database sync. It's obviously not up to date because this trial was built on September 6th. That was the last time it synced. But generally, if you have X-ray up and running, it will go and check for new vulnerabilities in every 24 hours. You can always obviously trigger the sync manually. And now it will go to all the public and private databases and get the vulnerabilities, the licenses, all the information about the packages. What you can see here are the violations. Before we go into looking at the violations, let's talk a little bit about the concept of X-ray in general. So what we have are two main concepts. The first is policies and rules without the policies, and the second is the watches. So policies are what we want to enforce. And when create a new policy, we can decide whether it will be security or license type of policy, and then we can add rules to them. So for security, it will be, I want to find all the vulnerabilities which are upper than a certain severity, or you can use the CVSS score and say, then express the minimal severity and maximum severity in this way. And then you can say, I want to generate violation based on those rules, and I want to trigger a webhook, for example, report to a Slack channel or notify by email, and then you can decide whether you want to block any further downloads of the artifact generated vulnerability from Artifactory, and whether you want to fail the build if this policy is used in a watch that connected to a CI server, like what we have in our example. Sorry. For licenses, the options are in the rules a little bit different. You can select only allowed licenses and create kind of an allow list, or which licenses should be banned, and then kind of create a block list. And then you can select which licenses from the ones we know should be banned or allowed, or you can add custom licenses, and then also select whether a license that we don't know or you don't know is actually allowed or not allowed. Again, generate violation, trigger a webhook, notify an email, block downloads, and fail the build. So once you configure the rules and you created policy, which is a combination of those rules, next will be a watch. Now, a watch is an application of a rule of an application of a policy on certain scope. And the scopes that exist are either every artifact that goes through Artifactory, or all the artifacts in a specific repository, or a specific build, and then you provide build name, build number, or all the builds that you have in Artifactory. And I would recommend scanning all the builds, because that's kind of a high level enough that you only care what you only catch what you care about. But from other perspective, it also makes sure that you scan all the artifacts that you really care about. Now, what you need to do now is assign the policies from the policies that you created. And once this is done, you're all set. Now, once the build is running, you can configure in Jenkins whether you want your build to fall or not. But in any way, X-ray will record the violation if one of the rules in one of the policies that are connected to this build actually trigger the violation. And this is our example. This is step 3, if you remember. So we can go here and take a look at what actually happened. And you can see, if you remember, there was tons of violations in Java. On top of that, tons of violations in the Docker image. And we end up with 87 pages of violations. That's a really, really bad build, and it's, of course, by design. So let's take a look at one of the critical ones. This one is interesting. So what you can see here is that we found vulnerability in Apache Struts 2 component. That's the one that took down Equifax a year ago. And we actually found it inside our WAR file. Do you remember the WAR file that we built in step number 1? We actually found it inside this WAR file, but now this WAR file is not standalone. It's inside a layer, which is inside the Docker image, which is inside the Docker build, but only by scanning the Docker build, we would be able to find it as well. We obviously found it much earlier because we scanned the Java build by itself, but even if we only scanned the Docker image, we would find it as well very easily, because we have this recursive scanning that goes all the way down and actually found the problem. So this is how the violation looks like, and we can take a look at the component itself and do the impact analysis, which is kind of the other way around. And we can say, okay, we have struts here. Well, it's not the latest version, so maybe the vulnerability was fixed. If I take the latest version, probably will fix it. But let's see if I have this problematic version in anywhere in my system. So I can look at ancestors here and see that, whoa, there are a lot of files that contain this vulnerability. And I can take a look at each and every one of them and say, okay, this one was a part of a war build by itself, right? That's the step one. But also it was contained inside a Docker layer. That's part of the stage 3. And they're obviously in the Docker build. And this Docker build, you remember the retagging latest N19? This is it. So we can take a look at the build 19 and actually see where it was used. So if I take a look here at the component details, I can see that build number 19 was actually in my Docker production repository, probably went to production. It's a shame that I didn't fail the build there, but of course, for the sake of the demo, that was the idea. So that's the setup that you have. And now going back to my presentation real quick, you can go and check your trial is obviously up and running now. It only took 4 minutes. And you can all download the PDF or open the documentation on the web and start actually seeing what I just showed you. Note the environment log. It has the username, which is admin, your custom password, and your unique ID. And you actually need to put your ID, unique IP, and you actually need to map your IP to JFrog local. And this is how I did it on Mac. So you can see here, that's my host file. And I have my IP that was a part of my environment log. That's the guy. It actually now matches JFrog local. And this is what allows me to actually go to Artifactory as JFrog local and not as the IP that has in the environment log. I hope that makes sense. So once this is done, you can obviously go ahead and play with it. All the documentation is pretty much the explanation that I did with you through the entire, the last hour. And what I want to finish is your questions. So if you look on your Zoom software, you have the Q&A tab, and you can go there and type questions for me, and I will be more than happy to answer. We have about 5 minutes, so we can take a lot of questions. And while you're doing that, I wanted to kind of ask you how was the content of this webinar. So let me launch this poll for now. And while it is running, I will check the questions. Here's the question. So artifact publish and X-ray input can't go together, a request to Artifactory. I'm not sure I understand the question. I think it might be about what is kind of a timeline of what goes where and when. I'll try to answer that. Maybe it will help. So the thing with X-ray is that it actually scans the artifacts in Artifactory. So you have to get the artifacts to Artifactory in order for X-ray to scan them. Now, your probable sequence will be deploy the artifacts to Artifactory, and then it will trigger X-ray scan, and then those artifacts will either be blocked or promoted through a next stage. So you first deploy, and then you scan, and then you act. They definitely can be on one stage, and this is exactly what we do in each and every stage. So let me just go back here and show you. If I look at my Jenkins files again, you can see here that for each and every step here, I actually do deploy my artifacts to Artifactory and then trigger the X-ray scan. So let me see. Let's test. Here, build and deploy. I deploy artifacts. That's stage number 3. If you remember, we deploy Docker image. So here we do Docker publish. Docker image goes to Artifactory, and then publish build info. Build info goes to Artifactory, and then after the test, we actually start X-ray scan of this build. So it will scan the Docker image that we just deployed. Well, I hope that that makes sense. Okay, what else do we have? Is it possible to configure X-ray and Artifactory using code like Groovy init scripts of Jenkins? Yes, absolutely. We have numbers of ways to do it, and that depend on how you want to roll out your Artifactory and instance installation. There are Docker images, there are Helm charts, there are chef scripts, there are tons of possible ways. All of them are completely scriptable. You can pass configuration, initial configuration for both Artifactory and X-ray. So it can be completely automated, you know, the rollout of your Artifactory and X-ray. And we actually have a demo of setting up the entire data center with Artifactory and X-ray completely programmatically. So yes, absolutely. Okay, what else do we have? Can we use Artifactory as registry without Nginx? Yes. First of all, you can use other HTTP proxies instead of Nginx. You can easily do it with Apache. You can easily do it with HTTP proxy and HA proxy, sorry. Configurations for both of them are inside Artifactory. So if you go to the configurations here in admin, you can, in admin, where are they? HTTP settings. Yes, so here in your HTTP settings, you can select a server provider, Apache or Nginx, or embedded Tomcat, and then generate the configuration there for any one of them. There is also HA proxy, and we have the example for HA proxy in our documentation. So yes, Nginx is not a requirement, and you can do it with embedded software, Tomcat, although we definitely don't recommend to use the embedded Tomcat configuration in production. I hope that helps it. There is another question. How many types of repositories out there? So there are four types of repositories. There are local, remote, virtual, and bin tray distribution. Those are the four types of repositories. Local repositories are there for deploying your files that no one else has, and you need a storage for them. Remote repository is a cache for remote registries and repositories like JCenter, like Maven Central, like NuGet Gallery or Docker Hub or whatever. And virtual repository is a gateway that kind of get you access in one URL to any number of local, remote, and virtual repositories. Bin tray distribution repository is, if you remember, we spoke about this when we spoke about the lifecycle. We spoke about software which is distributable and not downloadable. And sometimes you want to set up a public distribution of what you build. If you use bin tray, there is a very simple way to get your artifacts from Artifactory to bin tray in the right setup, in the right layout, with the right metadata by using bin tray distribution repositories. Now, on top of the four types of repositories, there are 32 different types of repository technologies, I would say. So if you create a new repository here, it will ask you what kind of repository you want to do, and you can see all the package types, and then you can see all the package types that you can create, and maybe that is an answer to your question. One more, kind of run out of time. Let's see. Imagine I have a custom license registered in Artifactory. Okay. And I have a license name to my POM XML and published and make an artifact. Okay. What process applies to the license to the artifact so it registers in meta information? And okay, so the way that licenses are registered in Artifactory and the way that artifacts are registered in X-Ray are a little bit different. In Artifactory, we discover the licenses by looking at the descriptors of the archives. So for example, we look at POM XML and see the license there. This is how we know what the license is. X-Ray uses external and internal metadata sources to match artifacts by their checksums to licenses which are known. So for example, there is a database that says that Struts2 is Apache 2 or LGPL, or I have no idea. We will send the request to this. Well, we will download the database to X-Ray and then ask this database, what is the license of this artifact? And based on the knowledge of this artifact, the license will be reported. X-Ray won't scan the descriptors for the license, but just match it with the database. So this is kind of the difference. And I guess that kind of, I hope that helps. So with that, I would like to thank you for attending this webinar and enjoy your trial environment. It is it is live for 4 days, and feel free to mess with it, delete artifacts, add new jobs, do whatever you like with it. And it doesn't have any impact on anything. It's completely isolated environment. And next step is actually downloading a real trial at jeffrog.com /Artifactory free trial. And this is where the stuff is getting serious. You actually have your own setup, which is for your organization, and you set it up with your data. And actually, this setup that you do there will stick around after you purchase a license or convert your trial license to a real license. So again, thank you very much, and I hope to see you in future JFrog webinars. With that, thank you very much, and bye-bye.